My research is involved with modifying the surfaces of materials. And when you think about it, everything in the universe has a surface. So therefore, if you can modify that surface in some way, therefore you can change the functionality. For example, if you have an artificial tooth or an artificial hip, if you can control that surface, then the body will be able to grow better into that surface coating. Likewise, if you're talking about generating energy, you can put a coating onto a turbine, which is a great big fan, so that the turbine can operate at a higher temperature. And by doing so, you're increasing the fuel efficiency by 3%. Or a third and final example could revolve around a corrosion example. So think about a petrochemical refinery plant or a steel-making plant. That infrastructure can corrode and will corrode because of the environment and the atmosphere under the operating conditions. If you put down a zinc or a zinc aluminium coating, then that will impede corrosion and thereby increase the revenue on operation for that industrial plant. I am but almost a figurehead for a very large team called SEAM, Surface Engineering for Advanced Materials. We are working on coatings for the future, either in the next 6 months or in the next 6 years. So what we're seeing is that we're looking at changing the chemistry of these surface layers so their functionalisation and their function can be more enhanced. What you'll see in concrete terms will be industrialisation and uptake by manufacturing industries, especially throughout the Victorian scene, which is very important. And you'll also see new economic development in those areas. You'll see startup companies evolving from this research, and you'll see patents proliferating in the near future as this new technology is transferred to the companies. And that is quite important for their sustainability, especially within the Victorian Australian scene. The impact of my research is twofold. First thing, we are training people. We're training them to think very critically about what questions to ask. So when they ask these questions and find answers to these questions, they can make a better product for the manufacturing industry of Victoria. It is important to think ahead and think about the serious problems that can give us some fundamental theory about why and how materials behave and perform. This prize better reflects on the people whom I've interacted with over the past 40 years. These colleagues have all taught me something, for which I'm eternally grateful. I've asked some pretty silly questions over the years, and from each of those questions I've learned a little bit more about science or a little bit more about myself. And I thank all of my colleagues for putting up with some of these questions and putting up with my drive to understand some of the fundamental features of material science. So for all of these people, thank you very much. I am Distinguished Professor Chris Berndt of Swinburne University. I'm the Director of the Transformation Training Centre in Surface Engineering for Advanced Materials, sponsored by the Australian Research Council. And I am honoured to receive the 2021 Victoria Prize for Science and Innovation in Physical Sciences.